Hello students. So in the chapter Units and Measurement, indirect methods are discussed these days. This is another indirect method for estimating the distance of not far off planet, as we have discussed already in a parallax method that is used for measuring the stars which are far away from us, even more than 100 light year away. But there are the things in space which are not so far from us. If you're having planets, if you're having something which is not so far from you, indirect methods are there, and one of the method is called radar method. Radar stands for radio detection and ranging. If I'm telling you what the radio means I'm talking about radio waves. These are the electromagnetic wave which can travel in free space in vacuum with a speed 310 power 8 meter per second. So what they generally do, suppose you are having a nearby planet or some object which is not so far from us. So this is the observation point. The radio waves are incident on those planets. After reflection from that object, it comes back. I don't know what the distance is between the observation point and that unknown object from where the radio waves are actually get reflected. With the help of very precise clock, we can measure the time lag between the sending of the signal, radio signal, and the receiving of the radio signal. And that time can be calculated with very accurate clocks. You know that this is speed or distance upon time. So, if you want to calculate the distance, which is called speed multiplied by time, the speed is of course of radio waves. Time lag we can measure with the help of some accurate clock. And you know that what the distance the radio signal has covered? It is not d, but is called twice of d. So d can be easily calculated with the word c into d divided by what? 2. So what is c? This is velocity of light, velocity of radio waves. The time we know that if you multiply c into t divided by 2, we will get the distance of that object whose distance is to be estimated. But dear students, if you are indulged with some type of numerical problem where indirect method is asked for, not in space, not in vacuum, but in a medium. Suppose I am talking about water. Suppose there is a boat equipped with this device called sonar. Sonar actually stands for sound navigation and ranging. You will study in the next chapter that sound travel faster in mediums. Light has another type of problem. Electromagnetic wave slows down when it enters into certain denser medium, but mechanical wave like sound that travel faster in medium. So in the case Navy or in some warheads, torpedoes which are used underwater, they always make use of sonar equipment because sound travel faster. Sound travel faster in water approximately 4 times. Sound travel much faster even in steel, nearly about 11 times as it can travel in air under standard condition. The speed of sound under standard condition at NTP in air is approximately 330 meter per second, but it becomes very fast in water. So if you want to measure the depth of sea, if you want to have some signal, you want to note down the enemy ships underwater or something underwater, sonar methods are used. The full form is called sonar, sound navigation and ranging. So have a look on the story. This is called speed, that is called distance upon time. With the help of very accurate clock, we can measure the time lag between the signal that is actually given or as given by this ship to the base and then back to the ship. We can easily find out that time also. So this time, if you want to calculate the distance once again, that is again called in the same wording of speed multiplied by time, the distance covered is again twice. And the speed is called the speed of sound in water. And the depth of the sea can be estimated, and in the numericals, this V, that is the speed of sound in water, will be given to you, and the time of calculation for sending or receiving this sonar signal is always given to you, and you can estimate the depth of the sea. Thank you.